in Korea. Rapid variation and extremes from climate change become a huge threat in cities that need to be overcome. In this context, to make citizen resilient is an essential topic to consider in urban management. So our first speaker is the Professor Soyoung Won, and let me check his titles because there is no titles to present him here. So Professor Soyoung Won will give a talk. The title is Contribution of Green Infrastructure on Urban Flood Mitigation. Alright, now Mr. Treni, I'll give my mic to Professor Soyoung Won. Right there.
Thank you, Professor Won, for your introduction. Okay, let me start my slide. Is everything clear?
Clear.
Okay, thank you. All right, let me start my presentation. The title of my presentation is Contribution of Green Infrastructures and Urban Population. Actually, Soyoung asked me to give a presentation several months ago. So I thought that it would be like a seminar on his institution, IWSSM. But I didn't expect this is an English presentation on a smart grid conference today. So my slides are not a specific research, but like a broad understanding of how the grid infrastructure, affect the mitigation of flood environments. Okay, this is the outline of my presentation today. I will shortly talk about green infrastructures and urban environment. And I will talk about the green infrastructure and the circulation of water in urban environment. Then I will talk about urban flood mitigation perspectives on how the green infrastructure affect effective in terms of urban flood mitigation in two aspects. First one is the flood scale, the other one is the cost issue. Then I will conclude my remarks. Okay, I think everybody understands this the effect of urbanization and impervious coverage. Impervious coverage is most characteristic things that urban environment has compared to natural watershed. And increase of impervious cover results in decrease in infiltration, like this, and decrease also in vegetation respiration. That would result in increase in direct runoff, and also its negative effects on biodiversity and extra species, and also problem risk increases. In terms of flood mitigation in urban environments, we have two solutions. First one is a structural method, and the other is non-structural methods. So among the structural method, we can categorize these countermeasures against the flood into two categories. First one is a gray solution, which is a conventional one. And the other one is green solution, which is corresponds to green infrastructures, LID, EMD, WSID, and other terms. So I will talk about these topics today. So what is green infrastructure? Is it like a nature compound? Personally, I think that the land and soil and this vegetation, trees, like components of green infrastructures. like if we introduce this natural component into city environments, it would be a green infrastructure. So the first definition was suggested by American Planning Association in 1994. They defined the green infrastructures as interconnected nature and spaces that preserve ecology and purifies air and water, and they are beneficial for human and other lives. In 2009, US EPA also defined green infrastructure, but in a very narrow sense. They talk about that the conventional green infrastructure, such as drainage network, have a single purpose, conveying water to other places. On the contrary, green infrastructure is cost-effective and a resilient approach for stormwater management that creates diverse ecological and social and economical benefits. So the definition of USFP is a little bit narrow. They define green infrastructure as one of the stormwater management, but the idea is that they understand the green infrastructure as it creates a diverse benefits, ecological and social and economical benefits. So this is like a changes in understanding of rainwater as valuable resources also. And the US Army Corps of Engineers also defines green infrastructure as a resilient engineer system that mimics a natural system or processes. Personally, I agree most on this definition of green infrastructure from USAC. EU Commission also define green infrastructure in a broad sense, which is strategically planned and designed and operated natural components for network of tools that provide diverse ecosystem services with other environmental planning. So they more focus on the ecosystem services that green infrastructure provides. So in a narrow sense, you can think of green infrastructure as a BNP or LID, which we were pretty much familiar with. But in a broader sense, as EU define, the green infrastructure has a large benefits and provides ecosystem services. So this is a diagram from Fletcher, and they categorize all these BNP, SUD, WSUD, LID in terms of its specificity and primary focuses. So in terms of specificity, it can be like a specific technique, single technique, but it can be like a broad principle. This is like more specific, this is more like conceptual. And in terms of primary focus, this is like a single process, such as urban stormwater management. And as you go further, it shows like a whole of urban water cycle management. So there's like a broad range of definition of green infrastructure, but green infrastructure actually includes all these concepts, such as BNP, SUD, LID, WSUD, and others. So green infrastructure is a broad sense. And I think the water cycle will be more proper interpretation in here. I interpret from Korean to English in haste, so a little bit awkward, but I think this slide is talking about green infrastructure and water cycle. Okay, so restoring. As we talk about urban environment, restoring distorted water cycle is a crucial environment. And circulation of water in urban catchment requires systematic approaches because because of its complex nature. And I think urbanization and its negative effects are like a worldwide problem. So we can think of this problem together and can find a solution together. So I think recently many research projects on green infrastructure is taking place. And more specifically, they focusing on the evaluation of how the ecosystem services that green infrastructure provides. In South Korea, we also have need to make efforts on the establishment of systems and legal backgrounds to introduce green infrastructure and develop it more quantitatively. In line with this, the Ministry of Environment of Korea proposed regulation of improvement of urban water cycle in last year, focusing on the developing a quantitative index, evaluating current status and planning for each region, setting a target, a water cycle target, considering regional conditions and local characteristics. More specifically, they suggest plannings and principles for restoration of water cycle like this. I think I have around 5 minutes. And there are some issues of Ministry of Environment regulation of water cycle. There's more specifically, there's like a curve number they use for the target index, we need a more proper indices for that. And the other one is the definition of water cycle ratio. And now the Ministry of Environment defined water cycle ratio as 1 minus runoff. So even in the natural environment, the water cycle ratio does not come to 1. So that's other problems. And the other one is standard rainfall, which is for evaluation, is set as 1 inch. The water cycle ratio actually varies and changes with depending on this rainfall amount. So it's another issue actually we have in South Korea. And there's like many green infrastructures depending on its effects and benefits. And in terms of flood mitigation perspectives, everybody asks and questions about the effect of green infrastructure on the effective flood mitigation because the effect of green infrastructure depends on soil types and limited by the potential infiltration. Many studies and reports demonstrate that the effect of green infrastructure on the flood mitigation effects, especially it is expected for small-scale events, which is more frequent actually rather than extreme flood. And the other cost issue in green infrastructure needs lots of areas because we need to change, develop areas which is impervious to pervious areas that expensive practices in urban areas actually lead to high project costs, which makes it difficult to introduce green infrastructure to urban environments. So what I'm thinking is introduction of this concept of directly connected impervious area, DCIA concept, which was actually more and specified in TR 55. So we can use CN cover depending on the introduction of the green infrastructure. So we can reduce this CN without changing the total impervious area, but the ratio of DCIA. So the concept of DCIA is very important because the total impervious does not change, but CN increases with decreasing DCIA, which eventually results in flood risk mitigation. So what I'm saying is we need to more focus on the connectivity of sculpture rather than the total area of WS areas. So I think this is a crucial concept to introduce DCIA and evaluate green infrastructures. There are some examples how United States EPA evaluate DCIA and how they evaluate a green infrastructure on this concept. But this is very empirical and it needs a lot of improvement. So we need to find a proper methodology to evaluate DCIA and evaluate green infrastructure based on DCIA also. So here's my concluding remarks. So green infrastructure can be defined in various ways. In a narrow sense, it's a stormwater management, but in a broader sense, it can be like an ecosystem services. And green infrastructure is essential for restoration of water cycle in urban environments. It can contribute to practical flood mitigation in urban areas. We don't need to improve. We need to improve the evaluation process of water cycle in urban catchment. And DCIN is a practical key to evaluate green infrastructures in urban flood risk, and more efforts are required for each country, I think, to elaborate on this assessment of DCIN and green infrastructure using this concept of connectivity. Okay, this is all for my presentation. I think it's 15 minutes, right? Thank you. Thank you very much.
We have enough time to discuss after this presentation. So instead of the 2 minutes, why don't we move to the next presenter? Next presentation will be given by Mr. 1 hour. This main part of the presentation is waterfront city in a changing environment. Give us the mic to Dr. Ron.
무슨 말인가요? 네. 실제로 이번 네, 그게 이거.
Thank you, Professor Wang. Can you hear me? Professor Wang, can you hear me?
Yeah.
Okay. Thank you, Professor Wang. I'm Dr. Wang from K-Water Institute. I have been working on land-ocean interactions. Actually, my colleague, Dr. Lee, is a specialist on urban design. Therefore, from our talk in today, we are talking about waterfront city in a changing environment. Actually, from this talk, I want to share our point of view to see coastal waterfront city in a changing environment. Therefore, our talk will be a kind of the point of view, not a detailed information about the waterfront city development. Actually, I'm the only person presenter in this session on floor. Therefore, our session will be really hybrid session. Then I took off my mask before every person have put on the mask right now. Then let me start my talk. Just wait a moment, we have a kind of problem. This slide shows our point of view to see the integrated view of water cycle. Sorry. Front. Yes, thank you. For water cycle, actually, we have integrated water resource management and upstream the watershed. In coastal area, we have traditionally integrated coastal zone management approaches. But these complex processes, we have multiple environmental stressors on coastal cities. We think we have to change these multiple stressors to develop coastal cities. And in the global view, there are changing and threatened waterfront zone issues. Many scientists have concerns on global impacts on waterfront and coastal zone, like increasing natural disasters and failure of ecosystem restoration efforts in 21st centuries. And for the planet operation system theories, we have many planet boundaries at risk, like climate change and biodiversity loss and nitrogen cycle. As you know, those issues at risk of planetary boundary systems are closely related with the water cycle. Therefore, we think the water cycle is a key pathway to restore planet boundaries at risk. This slide shows as a hotspot in the changing environment in the East Asia. That upper photo shows us a large marine ecosystem, but this photo says the large marine ecosystems is closely related with the watershed in coastal area. And also, our East Asian area is most severe human impact area. And the ocean circulation and ocean condition is also very focused on the warming, global warming around East Asia. Therefore, we are now talking about the changing coastal waterfront. From recent research, it is reported a recent increase in global wave power in coastal area since 1960s. Also, the typhoon is increased, both of the occurrence and intensity. Therefore, those recent reports are very closely related with coastal environmental issues to develop coastal waterfront cities, I think. More specifically, around the marginal seas and coastal area of Eastern Asian countries, including Korea and Japan, there are also reported increased global landfalling typhoons recently. Therefore, also the intensification of landfalling typhoons closely coupled with sea surface warming showed the sea surface warming around Korea and Japan. Nextly, the most important issue is sea level rise. In 2016, the BBC reported sea level rise factors are still unraveled. It means there are many factors to affect sea level rise since the 1970s. Therefore, we have to think about the more multiple and interactive impacts on coastal waterfront cities, including typhoon, sea level rise, storm surge, and upstream flooding. Therefore, we have more understanding about those interactive impacts to develop coastal waterfront cities. Now we are going to share our experiences in the Korean coastal area to develop the waterfront cities. From K-Water, we have two major developing areas, Siwa area and Nakdong Estuary area. Siwa area, we have Songsan Green City under development, and Nakdong Estuary area, we have Eco Delta City, grand cities. And futurely, in the near future, we are thinking about the new development efforts in Saemango area. Those areas have been reported to be mostly heavily influenced by sea level rise. Therefore, coastal flooding will be happening in these three areas. Also, the Busan area, the left panel shows the Busan area of coastal area will be reported to have mostly influenced by the coastal flooding during typhoon, considering both sea level rise and landfalling typhoon, very covered effect. Therefore, we have to think about those coastal effects to design and coastal cities. About our technology to develop waterfront cities, basically we apply the LID technology as a key approaches. As you know, in the past, Seoul has very good water circulation from previous, but now we have still many problems in water circulation in inner cities. Therefore, the Seoul metropolitan cities has reported water balance at undeveloped and developed sites with increased impervious surface. So we are trying to enhance the water water cycle and water circulation in our city development. About the coastal city, this photo shows our several efforts to enhance water circulation in many various aspects, include considering water cycle, evaporation treatment, detention reservoir, and infiltration harvesting, using many techniques from the LID approaches. Now, I'm going to talk about our three cases. First, in case one, we have more detailed information about Siwa area. And next two cases, I will show very short report. Siwa area has a very long history. We have been developing this area more than 40 years, long coastal waterfront city development. It started in 1977. Now we are still working on the developing this area. During the history, we have sea life destruction, 1986, and the coastal reservoir has a big problem about water pollution issues. Then we determined to develop the tidal power plant. Now, tidal power plant is successfully working now for water quality. Now the magnitude of the power plant is the world largest, and now still we working on Songsan green cities. Now I'm not talking about the details of the information, but we have challenging and developing many aspects of these cities from the north side to south side. Also, to develop these cities, we considering many aspects of water cycle, rainwater, seawater, and sewage treatment, water and groundwater cycle. Those are very different and important cycles of water resources will be considered to develop these waterfront cities of Siwa. Those photos shows how we designed to enhance the waterways around the Siwa reservoir to restore the water circulation after city development. Therefore, I think our long-time experience in Siwa area may have a good business story or business strategy for K-Water, the future city developments, including education and training, integrated operations, business learning, technical certificate, research and development, and exchange of publicity. Now I'm going to the second case, Dakdong-Yeshori area, Eco Delta City. Now this area is we are now developing the city design and water circulation policy. This area is actually the developing site, but the whole area is very various environmental issues and urban design issues, like ongoing upstream watershed management issues, such as river restoration and estuarine dike opening. And coastal zone issues, we have freshwater impacts issues and barrier island formation. These are barrier islands. So we think that these barrier islands will be very important to prevent coastal disaster like storm surge. Therefore, from the Eco Delta city design, we think we may provide a good model of water resilient and smart city as a future vision. The left side shows us the present status of the developing site. The right side shows us the future developed cities. Then this small photo shows smart village. We have a very small size of smart village for smart water city models. Therefore, the future, the Eco Delta city give us a very good model for the waterfront smart cities, I think. Lastly, I quickly share about the Semangdong area. This area has many issues ongoing now. The ongoing water pollution of coastal reservoir right here, and upstream river restoration issues also present this area. And estuarine dike right here. Estuarine dike opening issues are still controversy. And we think as an option, tidal power plant for water management green energy for this area, like Siwa. Therefore, if we have any chance to develop this area, it means revisiting the history of the Siwa area developing experiences from our last 40 years. And this is my last slide. In conclusion, I want to talk about the several environmental issues of coastal area. In coastal area, we have a very changing coastal environmental policy, right? That these are very multiple and complex. And as for the coastal waterfront cities, we have a challenging and threatening environment to be solved. For our company, K-Water, for our waterfront urban design, we have to utilize and maximize of our variety experience and lessons. Therefore, in the future, if we have a good global cooperation with K-Water experience, we may give a global best practice for future coastal cities as a smart water cities. Thank you.
So now it's let's talk to this Professor Yun-Sung Park, University. He's gonna give a talk about design circulation and response. Give us my mind to give a Yun-Sung. Right there. Professor Yun-Sung? You're not there? Professor Yun-Sung. I'm gonna try to call. Just a guy. He's now. Oh, okay. Yeah, you can start. Your mic. Professor Clark, your mic is not working. Are you using this to Chrome or other things? Things were what kind of browser you can browse code? You can't hear.
지금 이 상태는 여기서 이걸 해야 되는 거죠? 본인이.
네, 여기서 이게 아까 안 보였잖아요. 그래서 이쪽에서 선택하면 돼요.
Professor Clark is better using other browser. Do you have a Chrome? Okay, you have a Chrome, but I can't hear you. What should we do? It's not right to change the order of presentation. 5 minutes delay. So did you take the did you take his mic before?
Yes, the Professor Park has
Can you hear me?
Yeah.
Yes. Sorry. So somehow I couldn't get unmute my mic. I've been here all the time. By the way, I wasn't away. Just for your reference. Okay. So thank you so much for this opportunity to give a talk. And okay. I realize I lost quite some time already. I'll try to catch up. Okay. Can you see my screen?
It's good. Yes, it's good.
Yes. Okay. Thank you. So far we heard from Professor Sa and Dr. Wang. So Professor Sa talked about the green infrastructure for mitigation point of view in urban environment, and also Dr. Wang talked about the three waterfront cities that K-Water is developing. So I'd like to introduce. So my talk is clearly closely related to earlier talks. So I'd like to introduce the project I'm involved in, for which I'm taking. I'm working on very small part, but somehow I'm giving a talk. Anyway, so this project is to eventually to identify all the key technologies and in developing cities with water circulation in mind, and in the end with all the technologies and regulations in place, we'd like to get the come up with business plan in developing new cities. So this project is being done by 3 leading institutions in Korea, namely Seoul National University and Korean University and KAIST. And also I have to apologize that this talk is in Korean mostly. So it was not completely Korean in the beginning. I changed it quite a bit into English, but this just before the talk I realized I uploaded the talk to my cloud account, and which was the earlier version. Anyway, I'll try to make it. So at least the first one is English. So this is the key part for the project. So we have the researchers in diverse areas, and those are the expertise can be classified into three main categories. So one is focusing on hydrological or water circulation in urban environment, and also closely related to it is water quality, and also the final the expertise is combined with urban design and planning, and together we would like to come up with a business plan for the smart city with the water circulation, with healthy water circulation. So this is the main topics for the project. So clearly we have the urban part and water circulation part. This is 2-year project. In the first year, we focus on building the technology portfolios. Namely, so as I said, there are three groups. One is the urban design, but especially with self-sufficient water resources in place, and also for disaster reduction, we would like to come up with the plans for enhancing water circulation. But mostly it is LID, and in association with those, because there are always runoff, and we want to focus on reducing non-point source the contamination. So with these three technologies in place in the next year, we would like to come up with a plan to combine those expertise, and also based on this, we would like to nurture the environment, especially regulatory environment, to encourage adapting the new technologies that will come up with out of this project. Finally, we provide business plan to KO. That's the plan. So as I said, this is run by three institutions, and the PI is Professor Gon in SNU, and for the water circulation part is looked after by Professor Hang and myself at SNU. And water quality is studied by professors in Korea University. And for urban planning, it's done by Professor Kim at KAIST, and also urban design is led by Professor Kwon at SNU. So this is the plan for the project. First, developing individual technological portfolio is being done in the first year, which is being concluded soon, and in the next year there are three main topics. So the ways to combine those strategies and technologies from different area into one, so that we can come up with plans to introduce new regulations, and finally the business plan. And so that was the overview, and I'd like to briefly mention what each of us is working on. So I think this graph has been mentioned already by Professor Seo. So here we are focusing on WSUD and LID in this level, and here the focus, the idea is to adapt this concept into urban design. And for that, we start with reviewing the best practices on Earth. And there are quite a few examples worldwide, such as the one in Sweden and Germany and Japan. With this, we identify the technology for urban planning or for urban planning, and for the detailed level, we like to we even look at the design guideline for facilities. And for water quality part, we focus on resilience in water quality, especially in case for natural or man-made disasters. So for that, we would like to diversify the water sources and also commonly the plan to evaluate the resilience of the water resources. And so this is how we are going to diversify the water resources depending on the site. And so also for water circulation part, the key concept is to restore the water circulation or hydrological circulation in urban environment back to or close to natural state, as Professor Seo and Dr. Won mentioned. With the urban development, the two key parameters change, namely the filtration ratio. So the filtration decrease and runoff increase. Runoff in modeling point of view depends on essentially friction coefficient from the bottom, and the seepage is dependent on the coefficient of infiltration, and those increase with increasing impervious surface, and the identifying the each and every the LID technology, we'd like to assess the performance and also find out the way to optimally apply the techniques into urban design. And also for quality part, so we are also working on the improving the water quality of drinking water, and also reducing the leakage of water supply. And again, we'd like to use the smart technologies, namely smart water grid at this conference, and also smart water management. And eventually, with all the techniques in place, then we also need to have a way to monitor assess the situation or water circulation in general, and we do real-time monitoring and also database building. Then we can use those information to better management of water resources and water circulation. And here are some existing the regulations, the related regulations in Korea. But the outcome of this research and based on the review of existing regulation, we'd like to suggest how we can encourage this the urban design with water circulation in mind. And for that we'd like to help the details, the processes for example, LID, the evaluation and assessment, and finally, with this the outcome, we come up with the business plan, and hopefully Korea and the world is populated with water sensitive urban the sensitively designed cities. Okay, that's all. Thank you so much, and sorry for the hiccup in the beginning. Thank you.
Right, thanks so much for the presentation. We slightly late our schedule, but we don't worry much about because we have enough time for discussion, so we can reduce that time. So our last speaker is Professor Joshi Kinouchi from the Tokyo Institute of Technology. You can have Mike's mic from this moment. He's going to give a talk. Modality issues for the resident cities in Southeast Asia. Okay, we can start. Oh, I can't hear you. Did you turn on your mic? We can't hear. Professor Kinouchi, we can't hear.
Professor Kinouchi, could you please change the setting on your mic on your right side on your screen?
Red button on your right. No, it's not.
On your right hand side on your screen, could you can you not change the microphone setting? Could you please try again?
For now, okay.
Okay.
So I want to share. Maybe a little howling. There's some problem with the howling.
All right, yeah, maybe you can.
I feel a little difficulty in talking. Now maybe okay. Yeah, I will try.
Yes, it's okay. Just let's begin.
But I cannot show my face this time. Only voice. Is okay?
Yeah, it's okay.
Okay, now I can show my face and also I can talk over phone. You can hear me, right?
Yes, yes, sure.
Okay, sorry for taking time. I will start my presentation
No
by
problem.
sharing my slide. But before that, I have to introduce myself. Is that okay? Do I have some time? So thank you for inviting me to this international session. So also today, two of my students are joining to this session. Mr. Wenpeng Zhao and Ms. Liu Kexing is also joining. So let me start this presentation. Okay. Can you see this slide? Is it okay?
Perfect. Yeah, it's perfect.
Okay, it doesn't work at the top. So anyway, the title is shown here. I'm from Tokyo Institute of Technology. So today I want to share some tentative result of our ongoing study about urban flooding and its health impact in Phnom Penh City, Cambodia. So this is a joint project between Japan and Cambodia. So as you can see here, the Southeast Asia is included in this map. So many major cities are now experiencing rapid increase of population. So among them, the Phnom Penh also is showing the rapid growth of population and urbanization. So as you all know well, there are many pressures for urban flooding due to urbanization and climate change. Although Phnom Penh City is located somewhere inland, still have some problem with intense and frequent rainfall, and with increased population, they are also having some problem with flooding and also increased sewage and waste. That is the main reason of health impact. And here is the picture about the flooding in this city for 2012, 14, and 15. And even in this year, they had a few flooding events in the city. So one of our colleague did a questionnaire survey to local residents to identify the causal factors of flooding in the city, and they found these three major factors: heavy rain in short time, and small drainage capacity, and drainage blocked by garbage, which is not common in the developed country, but still this is one of the biggest problem in this city. And also they try to see what impact the people in the city suffering. And among these factors, health impact is also serious in the city. So why health impact is important? Because the flooded water include a lot of pollutant and also waterborne pathogen. That is the main cause of health impact, which is one of the focal point of this study. So to better understand the current situation in this city, I just summarized how the waste is treated in the central city area. So the point source from untreated wastewater and effluent from septic tanks are finally drained to this drainage channel. So about 60 to 70% pollutant or waste pass through septic tank. And during the rain period, the surface runoff and also garbage flushed into the drainage network and finally arrives to this drainage channel. And these pictures are showing the situation of extreme flood incident. So during the flood, flood water mixed with untreated wastewater overflows to street and increase the risk of infected those by direct contact during and after, even after the flood. And what diseases possibly happen? So there are some reports by Japan International Cooperation Agency called JICA in 2 different periods. So among many different diseases, skin disease, flu, diarrhea, typhoid, even cholera can be found. And also there are some other environmental problems causing nuisance to local people. And also the drainage capacities is affected by this kind of garbage. So with this background situation in the city, there are 2 main objectives of this city. First one is to predict impact of climate change and urban development on precipitation, flooding, and related health risks. And secondly, we want to quantify the effect of mitigation measures for urban flooding. So this figure is showing the steps to be followed in this project. First, I want to explain about this one, sub-daily rainfall projection in data scarce city, that is Phnom Penh City. So as I mentioned, in Phnom Penh, limited data is available for sub-daily rainfall extremes, although which is necessary for preparing for future urban flooding. So therefore, we estimated historical and future IDF curves. IDF curves, I think you know well, based on multiple model simulations of CCLID Codex SEA, which is the project using regional climate model combined with GCM with the resolution of 20 kilometer grid size. This is one of the reference paper dealing with this area using this dataset. So in our study, we used these 5 codex dataset with daily resolution for 2 different periods, historical period and future period with RCP 8.5 global warming scenario. And this data set were combined with observed rain gauge record from Ho Chi Minh City and Canton City in Vietnam for hourly resolution. But in Phnom Penh City, we can obtain only daily data set for historical period. And these information are processed to project the future IDF curves, for which we need to introduce spatial downscaling and also temporal disaggregation. For spatial downscaling, we use the popularly used method, one of the popularly used method, quantile delta mapping method, to downscale from grid size to station level. And the temporal disaggregation, we used ANN model to temporarily downscale from daily to sub-daily hourly resolution. So I don't explain the detail of this methodology. So then in the next step, we can obtain the IDF curves for historical period and future period for these 2 cities, Ho Chi Minh City and Canton cities. And as you can see from this figure, still we have a certain difference between IDF curves based on observation data and based on RCM codex dataset, so that these gaps are further reduced by introducing change factor CF to obtain future return rainfall. So with this process, we obtain IDF curves for Ho Chi Minh City and Kanto cities. And this information is further used to linearly prolate or to obtain the IDF curve for Phnom Penh City by linearly prolating these two IDF curves. And the result is shown here. So what we found, what we can see from this result is that future sub-daily rainfall intensity is projected to increase by 22 and 23% for 5-year and 10-year return level, respectively, in this city. And in addition, we found that current IDF curves for drainage design of Phnom Penh, which is calculated by JICA, are likely reasonable or likely underestimating the sub-daily rainfall intensity. This may be one of the reasons of the frequent urban flooding, although a certain drainage system has been introduced in the city. Okay, so next I will talk about the modeling approach for urban flooding. So there are many challenges included in this project because of the uncertainty factors or the lack of basic information. For example, land use data was not available when we started this project. We processed the satellite image to create the land use distribution data. Also, elevation data, reliable elevation data was not available, so we also created by our own self. And this is a study area, showing the study area. The drainage network data was obtained by JICA. And here, there's a pump to drain the storm water to downstream river. And also, we have been conducting monitoring of rainfalls and water level. And we did flow rate measurement, and we did sampling for analyzing water quality and pathogen. And with this all effort, we got this kind of result. This is a result applying to dimensional dynamic hydrodynamic model. And we can see almost everywhere we can see the inundation against the extreme rainfall have occurred in September 2014. And also we can see the maximum inundation depths declared from the local resident through questionnaire survey. Also, this map is showing the almost in any location flooding have been occurring. Beside that hydrodynamic model, we are also using a SWMM model, which is one of the popularly used rainfall runoff and the inundation model developed by EPA. I don't talk much about the detail of this model. So this figure is showing the comparison between observation and calculation of water level, flow rate in somewhere in the upstream and also downstream. So although the upstream side we find a very good agreement, but downstream a very large difference in observed and calculated water level. That may be because of the influence of garbage, as you can see here in this picture. And we are also trying to see the effect of some flood mitigation measures. Here some example measures are listed. Increase the pump capacity at the downstream end, and also increase the capacity of drainage pipe, introducing rain barrels, introducing permeable load pavement. All these measures are evaluated using SWMM. So this is the one of the tentative result for the rainfall event in this period, September 2014. So this figure is showing the maximum flood volume over this study area for each area, district area, and currently, compared to current situation, it's hard to see a large effect in reducing flood volume because the rainfall is a little bit large. But even so, measure 2, that is increased pump capacity at the downstream end of this study area, that is very effective to reduce the flooding in area 9. And overall, the largest effect can be achieved by introducing permeable road pavement in 75% of whole road surface of this study area. So next, I want to show you some tentative result about water quality, suspended sediment, COD, and E. coli. E. coli is one of the waterborne pathogen. So although there are some differences, we are still trying to improve the model accuracy. But a tendency during the flood period is quite well simulated. The concentration reduces during flood. So from this analysis and simulation, we found two major points. First, the high level of concentration of pathogens, even in flood water, is detected. So that implies highly waterborne diseases during and after flooding. And secondly, we found low efficiency of water treatment by septic tanks. Through our analysis, we found per capita loading of COD maybe around 110 grams per capita per day. And if we compare this value with the COD discharge, per capita discharge of untreated wastewater, that is really comparable. The value is almost similar. One question arises: are septic tanks well functioning? That we still further need to find the reason of these similar values. So I want to close my talk by showing this conclusion just including the important point I already explained. Finally, I have to emphasize that not only gray and green infrastructure, more holistic approach is necessary to mitigate urban flooding in the city, and more studies are necessary towards flood resilient cities under changing climate and urban development. Okay, thank you very much for your kind attention.
Thank you very much. Thank you very much. I think we are supposed to discuss, but I don't think we have enough time to discuss. So it's maybe if you have any question to, at first is the Professor Kinoch. Why don't we ask some question to him? Professor Salome, do you have any question? All right, so I want to have a question. Is that you compare this? What is the depend? If you look at the U.S. flooding and the runoff, then maybe so water height and the level was a different observation, and there's the your simulation, and then there's the garbage. But how about your water quality? Is the garbage still? I think the garbage will affect a lot to your simulation. So that is the first question. Then the second question, I think that you have many experience compared to your result is for you, based on your experience, I think it's based, for example, like your Tokyo simulation, and if you compare this to Phnom Penh and the Tokyo, then how about this? I'm sure that you can more simulate well in the Tokyo, but what do you feel about this compared both cities?
Okay, thank you very much. About first question, yeah, definitely garbage should be influencing water quality, not only some organic matter, but also pathogen may be included in the garbage itself. Yeah, that is my guess, and that's one of the reasons why the doesn't decrease much even during the flood period. And also maybe some sediment in the channel bottom, that can be another source of pollution during the flood. And second question, of situation between Tokyo and the cities like Phnom Penh. The data scarcity is the largest difficulty. When we apply the model, this kind of model to Tokyo, it's very easy to collect data. Very good information is available. But in this city, Phnom Penh, even the pumping record is not available. That is quite important for obtaining reasonable and reliable result. So the data limit is always challenging.
All right, thank you so much.
Thank you.
Yeah, I think so. We run out of our time, so there was some technical problem in our session, so we run out of all time, so we have enough time to discuss. Sorry, but what is the organizing committee is asking me to stop this on time. So I think so we need to finish our talk, our session at this moment. Right. Thank you for joining our session, and thanks a lot for the presentation today. Thanks. Thank you.
Thank you very much.
Thank you.